Hello students, today we are going to discuss the topic Allotropes of Carbon. This is Muhammad Jalil Ahmad, lecturer in chemistry, Dr. BRR Government College, Jadcherla, Mahbubnagar district. What is meant by allotropy? The phenomena of existing one element in two or more physical forms is called allotropy. It means that one element may exist in more than one number of physical forms. Nonmetals exhibit allotropy. Among p block elements, boron belongs to third A group. Boron exhibits allotropy. Among fourth A group elements, carbon as well as silicon exhibits allotropy. Among fifth A group elements, nitrogen and phosphorus exhibit allotropy. Among sixth A group elements, oxygen and sulfur exhibit allotropy. Among seventh A group elements, fluorine, chlorine exhibit allotropy. It means that non-metals only exhibit allotropy. Metals do not exhibit allotropy. This is the property of only non-metals. As far as carbon is concerned, carbon is a non-metal. Atomic number of carbon is 6. Carbon exhibits allotropy. Allotropy arises due to the difference in the arrangement of atoms in the structure. Contents of the topic: types of allotropes of carbon, examples of allotropes of carbon, structure of allotropes of carbon, properties of allotropes of carbon. Definition is given. Allotropy or allotropism is the property of some chemical elements to exist in two or more different forms known as allotropes of these elements. Allotropes are different structural modifications of an element. Allotropes are different structural modifications of an element. It means that allotropes possess same physical properties but allotropes possess same chemical properties but they possess different physical properties. Allotropes show similarity in their chemical properties but exhibit different physical properties. Allotropes of carbon. Actually, allotropes of carbon are classified into two types. They are crystalline allotropes and amorphous allotropes. Crystalline allotropes. Examples for crystalline allotropes are diamond and graphite. Diamond and graphite are the well-known examples of crystalline allotropes of carbon. Amorphous form means powdered form. Amorphous forms of carbon are coal, coke, charcoal, animal coal, lamp black, gas carbon, petroleum coke. These are the different amorphous forms of carbon. Here in this slide, totally 4 examples are given for crystalline allotropes. All the 4 are crystalline allotropes. They are diamond, graphite, buckyballs, or Buckminster Fullerene carbon nanotube. Allotropes of carbon are given in pictorial manner. Diamond is shown, graphite is shown, structure of diamond is shown below the photo of diamond. Structure of graphite is shown below the photo of graphite. Similarity is there in the structure. Difference is also there. In diamond, each carbon atom is sp3 hybridized, whereas in graphite, each carbon atom is sp2 hybridized. Diamond is a giant molecule. It is a three-dimensional giant polymer. Diamond is a three-dimensional giant polymer, whereas graphite is a smooth and soft substance. Graphite consists of hexagonal layers. Graphite possesses layer-like structure. We will discuss in detail about the structures of diamond and graphite in the next slide. Diamond word means unbreakable in Greek. Diamond is a metastable allotrope of carbon, where the carbon atoms are arranged in a variation of the face-centered cubic crystal structure called a diamond lattice. It means that diamond has a three-dimensional structure. It is a three-dimensional giant-like polymer. In diamond, each carbon atom is tetrahedrally bonded with four other carbon atoms. All CC bonds are very strong bonds. All of them are sigma bonds. Due to the three-dimensional structure, diamond is the hardest known substance in the world. Same thing is written in the next slide. Each carbon atom is bonded to four other to form a giant covalent network or lattice. The bond is of the same length and equally strong, so the carbon atoms are sp3 hybridized. As all the four electrons are localized. In diamond, all the four electrons of each carbon atom are localized, means fixed in position. Diamond is exceptionally hard and it does not conduct electricity. Diamond is the hardest known substance and diamond does not conduct electricity. The question arises, why diamond does not conduct electricity? Due to the absence of free valence electrons. Because in diamond, each carbon atom has got four valence electrons. All the four valence electrons are involved in bonding. No electron is left in free state. Due to the absence of unpaired free valence electrons, diamond does not conduct electricity. Diamond is an insulator. Structures of diamond are given. Each carbon atom is bonded to four others to form a giant covalent network or lattice. Due to the three-dimensional structure of diamond, it becomes the hardest substance. Due to its hardness, diamond is used as an abrasive, means for polishing purpose. Diamond is used for polishing purpose. Diamond is used in jewelry as a precious stone. Diamond cuts diamond. So for cutting glass, diamond can be used. So we call diamond as a glass cutter. Properties of diamond. Diamond has very high melting point. Diamond has very high melting point. Why diamond has very high melting point? Because all the CC bonds present in diamond are sufficiently strong bonds. Very large amount of heat is required to break sufficiently strong sigma bonds. Therefore, the melting point of diamond is very high. Diamond does not conduct electricity. Why diamond does not conduct electricity? Due to the absence of free valence electrons. Diamond is a good conductor of heat. Its melting point is very high, and diamond is a good conductor of heat, and diamond is a very hard substance. The reason of hardness of diamond is its three-dimensional polymeric structure. Due to three-dimensional polymeric structure, diamond is the hardest known substance. Fluorescence under UV light and X-ray. Diamond glows brightly under UV light and X-ray. So natural diamond does not glow very brightly. When it is polished, then it glows brightly. Due to total internal reflection, diamond glows brightly. Graphite. Graphite meaning writing stone. Graphite meaning writing stone in Greek. Graphite is a semi-metal native element mineral. Graphite is the most stable form of carbon under standard conditions. Here graphite is also called plumbago or black lead. Graphite writes black on paper. Since graphite writes black on paper, graphite is also called black lead or plumbago. Graphite is the most stable form of carbon under standard conditions. So graphite is a grayish black soft solid. In graphite, each carbon atom is bonded to three other carbon atoms to give layers of hexagonal rings. Graphite consists of hexagonal rings. Graphite consists of layers, hexagonal layers. In each bond, each bond is the same. The carbon atoms are sp2 hybridized. In graphite, each carbon atom is sp2 hybridized. It means that out of 4 valence electrons of each carbon atom, 3 of them are involved in bonding. Fourth valence electron is in free condition. Each carbon atom of graphite has a free valence fourth electron. The remaining p orbital electron is delocalized to form weak bonds between the layers. The covalent layer lattice has all sigma bonds. The covalent layer lattice has all sigma bonds. Graphite consists of hexagonal layer-like structure. These layers are held by weak van der Waals forces. Layers of graphite are held by weak van der Waals forces. The distance between the two layers is also sufficiently large, that is 3.34 angstrom. Due to these reasons, graphite is a smooth substance and also soft substance. Look at the hexagonal structure of graphite. Cc bond length in graphite is 1.42 angstrom. The distance between any two layers of graphite is 3.34 angstrom. Each carbon atom is bonded to 3 other carbon atoms to give layers of hexagonal rings. Properties of graphite. Because of the layers, graphite is an excellent lubricant as the layers can slide over each other. Because of layer-like structure, graphite is used as a lubricant in machinery. Graphite is also a good conductor of electricity because of the delocalized electrons. Example, carbon rods, lead pencils. Here, graphite is also a good conductor of electricity. Therefore, graphite is used in making electrodes. Since graphite writes black on paper, graphite is used in lead pencils. In making lead of pencils, graphite is used. Moreover, graphite is also used in making crucibles, which can withstand at high temperature. Buckminster Fullerene C60. C60 is so called Buckminster Fullerene, the one member of a family of spherical carbon molecules, sometimes called buckyballs. It has the formula C60. The carbon atoms are arranged in hexagons and pentagons to give a geodesic spherical structure similar to a football. C60 has a football-like structure. Like in graphite, each carbon atom is bonded to 3 others. Like in graphite, in Buckminster Fullerene, each carbon atom is bonded to 3 others, and Buckminster Fullerene has a football-like structure. In Buckminster Fullerene, like in graphite, each carbon atom is bonded to 3 other carbon atoms. Each carbon atom is sp2 hybridized. There are also delocalized electrons. Hence, C60 can conduct electricity slightly. C60 can also conduct electricity slightly due to the presence of delocalized electrons. Similarity is there between graphite and C60. In graphite, each carbon atom is sp2 hybridized. Here in C60 also, each carbon atom is sp2 hybridized. Graphite is a good conductor of electricity, whereas C60 can also conduct electricity slightly. Carbon nanotube. Carbon nanotubes, short form CNTs. Carbon nanotubes are allotropes of carbon with a cylindrical nanostructure. If you look at the structure of carbon nanotubes are allotropes of carbon and they have cylindrical nanostructure. Carbon nanotubes have a hollow structure with the walls formed by one atom thick sheets of carbon called graphene. This is about the structure of carbon nanotube. Carbon nanotubes have a hollow structure with the walls formed by one atom thick sheets of carbon called graphene. The chemical bonding of nanotubes is composed entirely of sp2 bonds, similar to those of graphite. The chemical bonding of nanotubes is composed of entirely of sp2 bonds, similar to those of graphite. Carbon nanotubes are the strongest and stiffest materials yet discovered in terms of tensile strength and elastic modulus. Carbon nanotubes are the strongest and stiffest materials yet discovered in terms of tensile strength and elastic modulus. Therefore, carbon nanotubes are used extensively in medicine and also in industries. Look at the allotropic forms of carbon. Carbon, atomic number 6, mass number of carbon is 12.011, and you can see the carbon carbon nanotube structures, diamond structure, and graphite structure. Graphite is used in making lead pencils. Diamond is used in jewelry as precious stones. For cutting of glass, we use diamonds. For making holes in rocks, we use diamonds. So for drilling of rocks, diamonds can be used. For cutting of glass, diamonds can be used. Diamond is used as a precious stone in jewelry, whereas graphite is a good conductor of electricity, therefore it is used in making electrodes. Secondly, graphite is used in making lead pencils. Third one, graphite is used in making crucibles. These are the uses of graphite. So among the crystalline forms of carbon, diamond and graphite are the most important allotropes compared to C60, that is Buckminster Fullerene and carbon nanotubes. Thank you.